Well, hello. Today is Friday, and this is the 10th day that we've been out. And here is linear and exponential practice. And so the first ones we're asking, tell whether the points appear to be represent linear. Remember, linear is going to be a line, and it's going to be the form of y equals mx plus b. It's going to be a straight line. Whereas exponential is going to have a curve. And a curve like this here is called decay. That's where the b value is between 0 and 1. So number 1, it's exponential. You can clearly see it starts continuing to curves here, then it's here and there and there, and it's going to flatten out like that. All right, number 3 through let's make sure we can see this. Yeah, there's 3. All right, so tell whether the points appear to be represent a linear function or an exponential function or neither. So remember, we got to compare the x's and y's. And so if we simply compare the x's and the y's in that type of format there, and so we can quickly see all the x values are going to be -3, -2, -1, 0, and 1. And all the y values are going to be 1, 0, 1, and 9. Now notice right off the bat, each one of these is a +1. So this is really consistent. So each one of these is adding 1 for the x values. But the y values, I subtracted 8 to get this one here. I subtracted 1 for this one here. I added 1 for here, and I added 8. So I would definitely not say this is not exponential. But I'm kind of curious as to what it is, because you notice 8, 8, 1, 1. It's kind of interesting. I bet if I graph that, that might be a really an interesting graph. Let's see what it kind of would look like. And so first point is -3, 9. So 1, 2, 3, and it's going to be a +9 way up here. And next one is -2, 1, about here, and -1, 0. We're on the y-axis. And then at 1, it's 9. Well, that's interesting. Here, and then it shot back up. That's kind of interesting. I don't think it's exactly parabolic. I don't think it's quadratic either. So this is a big neither. Because these numbers should be, second differences would be the same for quadratic. So the fact that we have this point here where we don't have 1 over there tells me it's just neither. Here's number 5. And we would probably do the same thing, x and y, and try to see if there's a ratio that's happening between each one of these. And sometimes you can just see it right from the very start. And so once again, x starts at -3, -2, -1, 0, 1. And the y values are going to be -9, -6, 3, 2, and 3. So each one, as you can clearly see, we're adding 1 each time. And here, I added 3, and then I added 9, and I subtracted 1, and I added 1. So once again, all these numbers are not the same, and even if I went to the second ratio there, this would be +6, this would be -10, and this would be plus 2. Even the second line is not, so this is another big neither. All right, here's number 7. Looks like a big long one. Let's see what we got here. All right, the table shows the demand of Y in thousands for a certain commodity where X is the number of months in the year. Okay, so X number of month, demand of the product, okay. Plot the given order pair above and let X be the independent variable and, oh sure, yeah, independent, and this is dependent. And use the function from part B. Write a function or a standard rule. All right, we got to plot the points first. All right, so this is going to be my months, and this is my demand, and I've thousands. I'm assuming this money. It could be 1,000 number of units, so this is just numbers. Okay, units. And so we're going to go. I'm not going to be super exact on this one. 2. So there's 1, 2, 3, 4, 5, and 6. And our numbers are going to go from 512 down to 16. So we're going to have to make these here. So we'll call this 500. 1, 2, 3, 4, 5. So this is 100 here. 200, 300, 100, 100, 200, 300, 400. This is 500, and this is 600. All right, so 1 is 512, is about there. 2 is 256, is right about here. 3 is 128, and then 64. 32 and 16. All right, so you can kind of see the general shape of this here, and it flattens out, really flat. All right, plot the given number of points above and let X be the independent. Got that? Write a function in standard form, the model of data. Well, we got to see how much is going down each time. And that appears to be about 50%. So remember, this is where I start, my rate, my time. So rate is going to be 0.5 because it's going half each time. And this is T for time. And we start out with, we got to figure out what it would be at 0. So we got to figure out if it's 0, 1 back from here. So that means it's doubles. So this is going to be right up here at 1,024. So at 0, it's going to be 1,024. So we're going to be 1,024 f of x equals, and that's going to be b in standard form. Alrighty. And during the function part, find the demand for the commodity during August. Well, let's see. The number of month, if we're assuming this is January, February, March, April, May, June, July, August. So we're going to put an 8 in there. So if August equals 8, and if that's the case, we'd have 1024, 0.5 raised to the 8th. And so if we have our handy dandy calculator, we clear it. And we take 1024, parentheses, 0.5, close parentheses, up arrow right here. Oh, you're not seeing any of this. All right, I'm gonna clear this. 1024, parentheses, 0.5, close the parentheses, this up arrow right here, and we're gonna put in 8. And enter, and the answer is 4. So there's 4 in August. So in August, 4 units. You know, like 4 units. It makes sense that if this was 16, if I could extend this graph out here, and this is the 7th month, and this is 7th, and this 8th month. This is going to be 8, and this is 4, and so it makes sense. I could certainly have made it like that to prove my point. I could definitely prove it like that to prove my point, but that's okay. All right, last one. Here's number 9. All right, so we're going to tell whether the table of values represents a linear or an exponential function and write the function. All right, so we can see the numbers increase by 1 each time. That's my x values. My y values increase by 3, increase by 3, because -5 plus 3 is -2, plus 3, plus 3, plus 3. So this appears to be linear because of all addition. If it was exponential, it would be multiplication. It's not. It was added each time. So remember, y equals mx plus b. M equals my rate, and that's going to be 3 over 1, or simply 3. And b is my y-axis intercept when x equals 0. So we can easily figure that out. If x equals 0, we 1 more here. And so instead of adding 3, we'd subtract 3, so it'd be -11. So 0, -11 would be the next point if I went to the left. So I'm going to say if x equals 0, y equals -11. So my equation is y equals y equals 3x minus 11. And I'm done.